the line that most animals don't cross. In between two of the islands of Indonesia, there's an ancient line that is both real and imaginable. You can't see it, but it's there all the same. If you stood on the coast of Bali and looked east to the shores of Lombok, you'd be staring right at the line's narrowest point, a 32 kilometers stretch of water that seems pretty unassuming. This invisible barrier weaves its way through the entire Malay archipelago, the largest collection of islands on the planet. On the western side, the animal life is characteristic of Asia, featuring rhinos, elephants, tigers, and woodpeckers. But cross the line, and things suddenly change. You won't find those same species on the eastern side. Instead, the islands have a totally different cast of ecological characters, including marsupials, Komodo dragons, cockatoos, and honey-eaters. This is what scientists call a biogeographic boundary, the meeting point of two regions of biodiversity that are highly distinct. And this particular line, called the Wallace Line, is perhaps the sharpest and most iconic of all. The Wallace Line was first sketched out in 1859 by a guy named Alfred Russel Wallace, a British naturalist who you might have also heard of as the co-discoverer of natural selection. That concept came to Wallace in a literal fever dream as he lay bedridden with malaria during part of his 8-year trip around the Malay archipelago. And while he'd end up being overshadowed by Darwin on that front, the second best idea he had on that trip was the existence of the Wallace Line. This idea helped to forever establish him as the father of biogeography, the study of the distribution of living things. He had spent his voyage observing and collecting as many species as he could, hopping from island to island across almost the entire archipelago. And it was as he moved east from Bali to Lombok that he first noticed something intriguing. Even though the islands were separated only by a narrow strait, the change in animal life wasn't gradual and subtle, it was sudden and distinct. Wallace saw the differences in animal life between the two. It was birds that initially caught his attention. Certain species that were plentiful on Java and Bali, like the yellow-headed weaver, coppersmith barbet, and the Javanese three-toed woodpecker that didn't exist at all on Lombok. And this abrupt shift extended to mammals and even many insects, too. Almost as if an invisible barrier was separating two different worlds. The biogeographic line that he drew, which others would tweak in later years, didn't just reflect the proximity of the islands. In fact, some islands on opposing sides of the line are closer to each other than many islands on the same sides are to one another. So Wallace realized that other, more mysterious forces must be in play. Like geology. He recognized that the geological past shapes the biological present. And, because the distribution of living species today partly reflects ancient geological events. He saw biogeography as a way to uncover epic chapters of the planet's history that might otherwise have been unknowable. And by taking this perspective, he concluded that the Western Islands must have once all been connected to each other, and to the Asian mainland. While today they are surrounded by shallow seas, this is only the result of a geologically recent rise in sea levels. How else could the big animals of that side, like tigers and rhinos and tapirs, have ended up on the islands? Because they're now separated by expanses of water that are way too wide for those species to cross. He had a similar thought about how the islands east of Java and Borneo had formed, at least some of them were the remnants of a former Australian continent. Wallace had a hunch that, throughout all of that change, deeper waters with strong currents between the two regions must have prevented many species from crossing from continent to continent when sea levels were lower. And this is still preventing many species from crossing today when sea levels are higher and the continents are fragmented into neighboring groups of islands. Even many flying bird and insect species obey the line, ones that aren't capable of crossing those stretches of open ocean. Wallace had pulled together many pieces of the puzzle, but he and other scientists at the time were missing one key idea to complete the picture: plate tectonics. The surface of the planet is not static, it's dynamic. It's made up of individual large sections or plates that move and collide over vast stretches of geologic time. We now know that plate tectonics shapes our planet in many ways, including forming and deforming continents, raising up island chains, and building mountain ranges. And studies have shown the Malay Archipelago to be one of the most complex tectonic regions in the world, a meeting point of multiple plates all jostling for space. And this is responsible for not only the area's many volcanoes and frequent seismic activity, but also the peculiar contrasts of its animal life. Because by the 1980s, scientists were able to say with confidence that the Wallace Line is, at its core, a result of plate tectonics. Wallace had correctly identified that two former continuous land masses had existed on either side of this line in the deep past. Today, we know them as the paleocontinents of Sundu in the west and Sahul in the east. Both of which existed during the ice ages when more water was locked up in ice and sea levels were lower. The Sahul continent of the eastern side of the line encompassed Australia, Tasmania, New Guinea, and the Aru Islands. And it only approached the Asian Sundu continental shelf in the west around 20 to 25 million years ago in the late Oligocene or early Miocene epoch. This was a result of the Australian plate slowly drifting north over tens of millions of years after breaking away from Antarctica in the south, bringing its distinctive community of birds, reptiles, and marsupials with it. These oceanic islands differ from the continental islands that flank them in that they were never connected to either of the greater land masses. They were ecological blank slates waiting to be filled in with whatever creatures could make it there. And those ended up being mostly species from the Australian side, seeing as the Wallace Line acted as a barrier to Asian species moving east. The Komodo dragon, a giant monitor lizard that today lives on a handful of islands in eastern Indonesia. Their fossils first appear in mainland Australia more than 3 million years ago in the Pliocene epoch, only reaching their current Indonesian island homes in the Wallacea region around 1 million years ago. And even now, the deep waters with strong currents that weave between the two regions, including the strait between Lombok and Bali, still limit the dispersal of many species across the line, keeping the differences in their evolutionary history so strikingly visible. This is what created the stark contrast bisecting the jungle of islands that Wallace first sketched out in 1859.